In Lab 4 demonstration, we observe the signal from a remote control. It is a digital message modulated with a carrier frequency around 38 kHz. The need for the high-frequency carrier, as discussed in Lab 6 Part 1 Step 2, is to allow the signal be distinct from noises and interferences, such as room light, or light from computer, TV, which do not have that particular fingerprint carrier frequency. The photoreceiver on the appliance tunes to that frequency like a radio tunes to a station. It only listens to the messages sent by the remote, and tunes out everything else. Lab 6 circuits are designed to demonstrate that communication technique, that is, amplitude modulation to distinguish the signal from noises and interferences. The circuits consist of band-pass filter from 3 to 10 kHz, and any interferences and noises outside that band are attenuated. The throughput signal is then input into a demodulator to recover the original unmodulated signal. In other videos, a demonstration of the circuits involves a simulated message signal that is amplitude modulated at 9.3 kHz, with added noises and interference that are either below 500 Hz, or modulated at 40.7 kHz, which are far outside the circuit band-pass frequency range. The demonstration shows the message signal is recovered in the original format, while the interference is largely blocked. In the follow, another similar demonstration of Lab 6 circuits is presented. It is different from the other demonstration. Here it simulates the case of the remote control. A LED will act as the remote control, but with 9 kHz modulation, which matches the band-pass filter in Lab 6. The photoreceiver that was built in Lab 4 will assume the role of the IR receiver on the appliance. Two sources of light will be the interferences. A flashlight that flashes at 250 Hz, which represents low-frequency interferences, and an actual remote control with a 38 kHz carrier to represent high-frequency interferences. The signal from the photoreceiver will be input into the circuit to test if it can tune in only the LED, and reject the interferences. The LED transmitter is driven by a simulated signal and its light output is coupled to the nearby photodiode. A small enclosure enhances the coupling between the LED and the photodiode. The photoreceiver output shows 100 Hz square pulse that simulates a message, which is modulated at 9.3 kHz square wave. The Fourier spectrum shows the carrier modulation peak. The photoreceiver signal is input into the bandpass demodulator circuit. The flashlight varies its light average output by generating pulses of different duty cycles. The modulation is 250 Hz. Even for flashlight signal with amplitude comparable with that of the LED, the demodulated output does not appear to be strongly affected. A remote control is used next. Its light is coupled to the photodiode via a small aperture at the top of the enclosure. The Fourier spectrum shows that the remote control modulation frequency is around 38 kHz, well outside the bandpass filter range. The remote control light signal, even at an amplitude comparable with that of the LED signal, does not appear in the bandpass demodulator output.